Nearly every person in the world uses or is affected by the principles of hydraulic theory on a daily basis. When you get up in the morning, you turn on the shower to get clean, you wash your clothes. That's hydraulic theory in principle, transferring the water to where you need it. When you drive a car, you're using at least three separate hydraulic systems to operate your car: the transmission, the steering, and the brakes. Hydraulic theory is basically the study of the movement and control of fluids and how they affect the objects around them or the vessels they are contained within. When a hydraulic system is working properly, it provides a system of precise control and very effective and efficient transfer of power. When hydraulic systems aren't working properly, you get one thing most normally above all, and that's a mess. They're messy, and you got to clean it up. When a leak happens in a hydraulic system, that's where the mess happens. Now, you can have a leak in your car, you can have a leak in a backhoe you see digging a ditch, you can have a leak in your body. A bruise is a leak in a hydraulic system. A bloody nose is a leak in a hydraulic system. A more dangerous and damaging one would be a stroke, which is a leak in your brain. These things are real and they affect everybody. Now, a simple understanding of hydraulic theory and how it operates in the world will help you to understand what's going on around you, things you see every day, and things that affect your life every day. And it'll help you understand how these things work, how they help you, and understand the dangers involved with them. Now, the basics of hydraulic theory and how and who some of the people who use hydraulics on a daily basis is what I'm going to talk about. Now, when I talk about hydraulic theory, first I always like to talk about how you measure it. You measure it most commonly in PSI, pounds per square inch, a simple thing that most people don't really understand. When they say PSI, they think about their tire pressure. 32 PSI, 35 PSI, if you're riding a very high expensive bicycle with those really narrow tires, 95 PSI, or a 18-wheeler or a large truck, up to 125 PSI. What does it mean? Pounds per square inch is the force of the fluid inside the container, and it's always inside of some container, pushing on the walls of that container. Now, if you have 10 PSI pushing on a surface area of 10 square inches, like a simple cylinder pushing up on a surface area of 10 square inches, that surface area will be able to lift 100 pounds up, or move 100 pounds, exert 100 pounds of force. The force, the pressure, multiplied by the surface area equals the force coming out of it. The simplest hydraulic tool, and I think the most basic one to explain, is a hydraulic jack. Now, a hydraulic jack operates very simply, uses that same basic principle: force, or hydraulic pressure times surface area equals force of lifting. Now, what makes it interesting is you are providing the force, inserting the force into the jack by pushing down on a cylinder that is very small and has a very small surface area. Now, the cylinder that is actually lifting whatever you want to lift, your car or whatever, has a much larger surface area. So when you create pressure here on the small surface area, 10, 20, 50, 100 PSI, even though you're only making that pressure in that small cylinder, when it transfers over to the big one, the output force can be multiplied as many as 10, 20, 100 times. It's the difference, the ratio between the input surface area in the output surface area multiplies out to become the effective force that you're going to put out. Jacks are very simple. They're very common. Everybody uses them. Now, the last thing I said I was going to talk about in this part of my presentation was the people who use hydraulic systems on a daily basis. Of course, you have your mechanics who fix, repair, and modify hydraulic systems on a daily basis. That's what I personally do. I fix hydraulic components for military aircraft, and it's been my livelihood for the past 20 plus years. To me, it's very simple, and it's what I've always done since I became an adult. That job is the most common and one most people, I guess, would think about when they think about hydraulic systems. They think about it at all. Then you get into aircraft pilots. They have to understand the hydraulics because they have to fly the plane. If something goes wrong, they've got to know what happened so they can get it down safely or eject or do whatever it is that's required to do to get their plane or get themselves safely on the ground. Engineers, just about every engineering field that I can think of uses it. One of the most common, of course, is civil engineering and mechanical engineering because they deal with fluid power all the time. Dams, hydraulic systems, cars, things of that nature. One of the areas that I don't think people think about is medicine. Doctors need to understand how hydraulic systems operate and how they function because they need to understand what can cause a hydraulic system to fail. When we talk hydraulic system failure, we talk leaks, we also talk blockages. And to me, the blockages are the biggest problem, at least for doctors. The leaks are less common, but they happen. There's not a lot you can do about it unless you're inside the human body at the time that happens. But a blockage, that causes heart attacks, causes people to die from embolisms, from clots moving through the body and getting stuck in the lung and destroying heart tissue. These are things doctors study. They also study how if veins are compressed or shrink or the arteries shrink, how it affects blood pressure and can have other effects on the body. And that's one of the things that people study when they talk about why you shouldn't smoke or use nicotine, because it causes the channels that the fluid is flowing through to constrict. Now, what I want to move on to is, now that I've talked a little bit about what hydraulic theory is and how it operates, and who the people who use it is, I want to talk about how it aids us and how we use it as a population every day.